Alright, so today we're going to do 1.2, which is going to be linear relationships and equations. Back of the board right there, write your name, and then you can take one. So first thing we're going to talk about is going to be function notation, okay? So function notation is when we represent an equation in the form of function notation. So the way that we would rewrite it is instead of y, we're going to write f of x, okay? And this is where x is the input and f of x, aka y, is the output, okay? Input versus output. Every single function has one, and you can evaluate either one based on being given one piece of information. You can find the other. Function notation is specifically useful for finding a value in the range that corresponds to certain domain values. So when they give you something like this, f of -3, that's telling you to replace the x with -3, okay? So if we were to do that here, we want to evaluate what f of -3 is. We would simply replace the x's in the equation with -3, which is going to come out to be 2 times -3, which is -6. -6 plus 7 is 1, okay? So that's how you would go about doing that problem. So do we have any questions about basic function notation? Okay. So now we're going to use the functions provided to us in these questions to evaluate these different questions that they've asked us. So the first one says g of -7. So what we're going to do is we're going to take that g of x function and we're going to replace all of the x's in it with -7. Now when you go about doing that, please just be careful that you're putting things in parentheses, okay? Now here is where things can get a little tricky. What is a negative number squared? A positive, but we have that negative sign on the outside, so this one actually is going to end up becoming negative ultimately. It's going to become a -49, okay? What is 9 times 7? 63. Okay. And then we have g of -7 is equal to, so in my calculator I'm going to do -49 plus 63 minus 1, and we get 13. So g of -7 is equal to 13. So does anyone have any questions about that? Yes?
Why was the 49 negative?
Because of this negative out front. So when you square it, it becomes positive, but because there was that negative, it became negative again.
Why is that 7 negative and the other 7 positive?
Oh, you're right. We made a mistake. Thank you. Thank you for pointing that. Does anyone else see it?
Yeah.
I accidentally plugged in a regular 7. Sorry about that. I didn't remember the answer being 13 last period, so I should have been a red flag for me. Sorry. It's that. So it's actually -49 minus 63 minus 1. It's -113. So I apologize. That sounds more like it. So check your signs, everyone. Check your signs. Are you ready to try the next problem?
Yes.
Okay. So this question, it's asking us to subtract these two evaluations. So I'm going to do this one first. Then I'm going to plug it in again into this one. And then once I get my result, I'm going to subtract them. So the first thing I'm going to do is I'm going to replace the x and the f of x function with 1. And that's going to be minus, I'm going to take the function again, and now I'm going to plug in -4. And if you're wondering where that all came from, this one is this one, and this one is that one. And the negative sign is from the original question, okay? So everyone understand where that came from so far?
Yes.
Okay. Now we're going to multiply. What's -5 times 1? What's -5 minus 14? Good. good. Negative 19 minus, what's negative 5 times negative 4? What's 20 minus, good. What's 19, negative 19 minus 6? Negative 25. That's our final answer. So it's just a lot of evaluating. Algebra 2 refresh. Algebra 1 refresh. Alright. Next one, we're just going to take the g of x function and replace each x with 12. And then we have that times 2 on the outside that we're going to apply later. Okay? So that is just this. Alright, what is 12 squared? Good, but it's made negative. What's 9 times 12? 108. Minus 1. So that's 2 times. I'm just going to do it in the calculator. 144 plus 108 minus 1 is negative 37. Times 2 is negative 74. Alright. Now we're going to evaluate in a little bit of a different way. As you can see in this question, something's a little bit different about it. They're not giving us an x. They're not giving us an input. They're giving us an output. So when we're given an output, instead of plugging in for x, you're going to plug in for the p of x. The whole p of x is going to get replaced with that number, and then you're going to solve for x. So I'm going to rewrite the equation, but instead of p of x, I'm going to write negative 23.5. So I'm going to just rewrite it. And now I'm just going to solve for x by trying to get x by itself. The easiest way to get started doing that is to subtract 1/2 on both sides. 1/2 is the same thing as 0.5. So negative 23.5 minus 0.5 is negative 24, right? So I have negative 24 is equal to 4/3 x. So is everybody on board with how I got there? Okay. Now you have a few different options on how to solve this. There's not one right or wrong. Well, there's definitely wrong ways and right ways, but there's multiple of them. You can do reciprocal method, where you multiply by the reciprocal of the fraction on both sides. So say we multiply by 3 over negative 4 on both sides. The purpose of that method is it allows us to cancel these out right here. Okay? And then over here, when you go to multiply a fraction by a number, you just multiply the top of the fraction by that number, and then once you get that answer, you can divide it by the denominator. So 3 times negative 24 is negative 72, all over that original negative 4 denominator, which is equal to x, which can be simplified, I think, 18, yep, thank you. So x equals 18, and the way that you're often going to see that written, it's going to say p of 18 is equal to negative 23.5. So what that's saying is, it's like, that's way of the function notation way of writing an ordered pair. That's like saying 18 comma negative 23.5. Any questions? Okay, perfect. So the next question, we're going to use the q of x function, and we're going to be plugging in 4.5 into that function. So it's going to be 7 minus the absolute value of 3 times 4.5 minus 4.5 to the 3rd power. Okay. 7 minus 3 times 4.5 is 13.5. And then 4.5 to the 3rd power is 91.125. Now we subtract 13.5 minus 91.125, and we get negative 77.625. Now, what do these bars around that number indicate? Good. If it's negative, it's going to become positive. So once I make that final answer positive, and you can only evaluate an absolute value once you get to the very end. You have just a number left. Okay, you have to evaluate inside, then you take that absolute value of it. So it's going to be 7 minus whatever that is. So 7 minus 77.625 is equal to negative 70.625. So a little decimally, I don't know how you would say it, but it's a lot of decimals involved, but do you get the idea of how it works now?
Why is it not?
Yeah.
Why is it negative if we just made it positive?
It's not negative, it's subtraction. So
Okay.
I made this positive, but there still exists subtraction outside the absolute value that we have to apply. Does that make sense?
So wouldn't it be like 70.62 or?
At the end, no, the absolute value bars are gone now.
Okay.
They only make things positive that are inside of them. Once they're gone, you just treat it like a normal problem. Okay. Alright. So the next one, we're going to plug in negative 1 into the p of x function. So we have 3 times 1 half minus 4 thirds times negative 1 plus 5. Okay. When you multiply a negative times a negative, you get a good. Now, when we go about adding these, we have to find a common denominator, which is 6. So isn't 1 half the same thing as 3 over 6? And isn't 4 thirds the same thing as 6 over 8? The purpose of me doing that is so now we have the same denominator. So that's going to be 3 times 11 over 6 plus 5. And then when you want to multiply a number times a fraction, you multiply the numerators, keep the denominator. And now I can put this in the calculator. So 33 divided by 6 is 5.5. So 5.5 plus 5 is 10.5. And you can reduce this less steps. I'm just trying to show you all the steps so nobody gets lost in what I'm doing. Yeah.
This is for number 4, but how can you get negative 23.5 become negative 24?
This isn't the answer. Oh, I'm subtracting a half from it. Alright, you guys ready to move on? Okay. So, for the next problem, we're going to talk about linear relationships. Guys, can you stay focused, please? Thank you. So, when points on the graph lie along a straight line, it is called a linear relation. Linear relations can be represented by an equation. For example, this equation in this graph can be written as x plus y is equal to 8. So there are 3 main forms for linear equations and linear functions and whatnot. We have standard form, slope-intercept, and point-slope. Okay? They can all be converted back and forth from each other. So we're going to use different forms for different reasons. Okay? And there are some special cases for slope that we're going to talk about. A vertical line has what we call an undefined slope. So if you want to write that down, feel free. So your slope is undefined for a vertical line. And horizontal lines have a slope of, anyone know? 0. Very good. So your slope is 0 for a horizontal line. Alright. The other 2 types of slope are negative, positive. So let's talk about parallel and perpendicular lines. So The slopes of parallel and perpendicular lines are always the same, okay, or equal. And the slopes of perpendicular lines are good. So you're going to see it written sometimes as opposite reciprocals or negative reciprocals. Both are acceptable. So just be aware that it can be written opposite or negative. That just means that the signs are opposite, different, and the fraction is flipped. Okay, reciprocal is flipped. So let's talk about intercepts. An x-intercept is where we cross the x-axis. And every single time that you have an x-intercept, it's always, always, always forever going to have a y-coordinate of 0 every time. Okay? Now, a y-intercept will always be where you cross the y-axis. And it's always going to have a x-coordinate of 0. You see that? Because that's where there are no, it's right on the axis. So there is no x. There's no left-right movement. With the x-intercept, there's no up-down movement. It's right on the axis. Okay, that's what defines it to be an intercept. Intercepts always have 0 as their opposite variable. So we have identified the x and y intercept. And just a little fun fact and review from yesterday, functions will only ever have one y-intercept. If it had more than one, it wouldn't pass the vertical line test. So always make sure if you're talking about a function, it's only ever going to have one y-intercept. So the x-intercept is also referred to as, any ideas? What'd you say? No. No one? Alright, I'll give you the first one. It can be called the 0. Does that ring a bell? Yes. No, we do. That is a good math word, though, we use. Any ideas? If you find the answer to a problem, you found the solution. And lastly, we have roots. It can be called a root. So did those all kind of ring a bell a little bit to you? Hopefully? Okay. So, we're going to do a word problem together. So, it says here, the function y equals 2x minus 150 represents the money raised, y, when the boosters sell x soft drinks at a baseball game. Find the 0 and describe what it means in the context of the situation. So first and foremost, what is the independent variable here? That would be your dependent.
Your x value.
Yeah, my x value, which represents what in this case?
How much money you get.
That's the dependent.
The amount of soft drinks.
Yes, soft drinks.
Soft.
So, soft drinks that you sell controls the amount of money you make, right? So, soft drinks is independent, and dependent is money made. Hello? Yes. Wait, I don't have that, student. All the time. Okay.
Is it me?
I don't think so.
Ace.
Yes.
Briar.
Yes, it's you. Yes, go ahead. You're dismissed. I thought it was a different student that she said.
Mom graduating?
So anyways, let's find the 0. So, in order to find the 0, we need to plug in 0 for which variable here? Y. Because whenever you want to find a 0, you're always going to be plugging in for the y. So then we're just going to solve this. X equals 75. So my 0 is going to be 75 comma 0. That's where we cross the x-axis, right? What does this mean in context? Yes.
After he sells, or they sell 75 drinks, they'll start making profit.
Very good. So they need to sell more than 75 drinks to start making a profit, right? This is them breaking even. So the context is breaking even. Because they need to sell at least 75 drinks just to get the money back that they put into the business. Does that make sense to everyone what I'm saying by that? Okay. Now for the next problem, we're going to go ahead and graph this thing. And we don't need to graph the first problem. I know there's a graph there. You can do that if you want to, but it's optional. So first thing we're going to do to graph is we're going to plot the y-intercept. And then we're going to go down 1, 2, 3, and then to the right 1, 2. And then we're going to connect it like this. That wasn't really that great of a connection. Okay. So we're going to then list the characteristics of it. If this is a linear function, what is its domain? Negative infinity to positive infinity. What is its range? Good. Every linear function has the same domain and range, unless we're talking about restriction. Does it pass the vertical line test? Is it continuous or discrete? What is my x-intercept? Good. And my y-intercept? Good. Do you all understand why the 0 goes where it goes? And what's my slope? Good. So does anyone have any questions about those key features of the graph? Okay. And the last thing we're going to do is we're going to look at some functions and convert forms. So the very first one, it has given us a function. What form is this function in of the 4 forms we talked about today? Point slope. And we need to get it into slope intercept to figure out what we want. So I'm going to write it down over here. And I'm going to use the distributive property. That's going to give me y minus 3 is equal to 2/3 x minus 8/3. I'm now going to add 3 and here's the problem. When I do that, I'm trying to add negative 8/3 to 3, so I can rewrite 3 as 9/3, right? To have a common denominator. What's negative 8 plus 9? So I get 1/3. So y is equal to 2/3 x plus 1/3. That's my equation. And what is the slope in this case? Good. So you can write it on your paper. This is slope, and this is y-intercept. Okay. Do we have any questions about that? All right. So the last 2 questions we're going to look at are going to be rearranging problems to get them into, they're in what form right now? Good. And we want to get them into? Good. So the easiest way to get something into slope-intercept form is to solve for y. So to get y by itself, we're going to start by subtracting the 10x, right? So we get 5y equals negative 10x plus 5. We divide everything by 5. And we get y equals negative 2x plus 1. Over here, we want to get y by itself, so we subtract 16 on both sides. We get negative 1x minus 16 is equal to 2y. And we divide everything by the 2. We get y equals negative 1/2 x minus 8. So now they're both in slope-intercept form. Are the slopes parallel, perpendicular, or neither? Neither. But they're reciprocals, so what's the problem? Yeah, they're not opposite. They're the same sign. You can't have the same sign for reciprocal, opposite reciprocal. And the last one. Subtract 8x on both sides. We get negative 6y equals negative 8x plus 42. Divide by negative 6. We get y equals 4/3 x minus 7. And then over here, I'm going to rearrange this real quick. So first thing I'm going to do is I'm going to rewrite it like this. So does everybody see what I did there? I just want to get it into slope-intercept form, so I have to rearrange those two terms. Now I can divide by the negative 3. What's a negative divided by a negative? Good. So you get 4/3 x minus 3. And what do you notice about those slopes?
They're the same.
Good, so it's parallel, right?